I am joined now by Andrew Gayle. Congratulations to you and Dr. Robert Cook on being named the JMR Paper of the Year. The title of your paper is Mapping Viscoelastic and Plastic Properties of Polymers and Polymer-nanotube Composites Using Instrumented Indentation. Tell us about the work being presented in this paper.
Thank you. Firstly, thanks for having me. Dr. Cook and I are very honored to receive this prestigious award. So the research that went along with this paper is pretty interesting. We first started off with just looking into the properties of carbon nanotube polymer composites, and you might have heard of carbon nanotubes. They're pretty cool materials. They're sort of a super material, so they're really strong, pretty flexible, and really lightweight, which is important when you're building something. And they also have really interesting thermal and electrical properties. But the main problem with them is that they're really hard to manufacture currently and make them in a useful form. The one way to get around this is to put them in a plastic composite, so you just throw them in some plastic. But the problem with this is that they tend to coalesce or form clumps of carbon nanotubes, and we didn't know how this affected the properties of the whole material. So we tried finding the properties over the course of the surface of one of these materials, the clump, and then the area around the clump. And the way that we did this was using nano indentation. So essentially we just push into the material, and then we can get some time-dependent data and then use this data to figure out properties like strength and how it changes with respect to time and stuff like that. So the really interesting thing that we did, the second really interesting thing, is that the way that we analyzed this, we also took into account time dependence, so how this thing changes or becomes weaker over time, which most papers and research doesn't take into account just because it's really hard to analyze. And the really interesting thing is that we can now, since we have this protocol for analyzing, we can now use this for other polymers, other plastics, and analyze their properties and figure out where they would best be used.
Well, you talked about practical application just a little bit. What are some of the practical applications that do stem from your work? Are there any devices or products that stem from your research thus far?
So this research is pretty recent. It was completed about 1.5 years or 2 years ago. So directly from our research, there are no real applications that I know of, but carbon nanotubes themselves have pretty much infinite applications because, as I said, they're really light and they're really flexible and very strong, which are super desirable. So they're in a class of materials known as polymer composites, which are like fiberglass or carbon fiber reinforced polymers, which are both used for things like airplanes and boats and cars and stuff like that. But because they're so lightweight and so strong, the applications are practically endless. And now we know their properties a little bit better, and we know how they can be used better. And the other half of the research is now we know how to analyze other polymers, and we can figure out how those would best be used.
What have you been working on since the publication of your paper, and what are some of the obstacles that still exist in the field, would you say?
So, as I said, this research was completed about 1.5 years ago, so I went back to NIST where this was performed, this research was performed last summer. Dr. Cook and I worked on figuring out 3D nanoscale strain in single crystal silicon, which again is a mouthful, but pretty much they're useful for like nanoscale devices, which are becoming a lot more popular as time goes on. And as for the second question, some other obstacles. So our model is, as far as I can tell, a pretty great leap forward in analyzing polymers and polymer composites. But it's not perfect. The time dependence is still really hard to analyze. So I'm sure in the future people will figure out better models and better protocols for that. And also in terms of carbon nanotubes, this isn't exactly my area of expertise, but I know that, as I said, the problem with it right now is manufacturing. And once they figure that part out, then they can be used in pretty much endless applications. I know they're considering use in like space elevators and really cool things like that, where we could make space travel a lot easier.
That would be very cool.
Yeah, it's a very exciting field.
Well, congratulations on your paper, and we thank you for joining us, Andrew Gayle.
Thanks for having me.